students. So I decided to make small 3 videos. This one will be for Taylor series and next one would be for Lorentz series. Okay, so Taylor series, when you expand a given function fz in Taylor series expansion, a function fz, so condition is that is analytic inside a circle. So if fz is analytic inside a circle, so what you have, fz, this should be analytic inside a circle. Circle could be this is equation of circle, right? I hope you understand. This may be represented inside this circle as a convergent power series. If this condition fulfills, then this fz can be written as a convergent series. How? An into z minus z naught to the power n, where an is what? 1 upon factorial n, and nth derivative at z is equal to z naught. Okay, so this series is also one of the property of this series is unique. So no such other series can exist. That's what it means for unique. Okay, so if z naught equal to 0, then you have another series an z to the power n, right? And n equal to, by the way, 0 to infinite, and an would be what? 1 upon factorial n f of n of 0. So this special series is known as Maclaurin series. Okay, so special form of Taylor series is Maclaurin series. So all this expansion can be done for real space as well as complex. So these video series comprise only for complex space, that means complex system, not for real. Okay, now we will take an example, fz is equal to 1 by z, and we will expand it about z is equal to 2 in the form of Taylor series, and we will find the radius of convergence. Alright, so just hang on and let's just do it. Okay, so you are given fz is equal to, I have taken this very basic, fz is equal to 1 by z, and you have to expand it about z is equal to 2 so that you can practice for more complicated question. So how can you do? 1 by z is equal to sigma n equal to 0 to infinite an. So I will tell you by two methods. Okay, z minus 2 to the power n. This is the formula or method that, or concept that I just taught you, right? Just a few seconds back. Okay, an is equal to fn 2 upon factorial n, right? Factorial n. Alright, so now what is fz? You already know what is f prime z. First derivative minus 1 by z square. What is second derivative? Minus plus 2 by z cube, right? So similarly you can find nth derivative, right? And that would be minus 1 to the power n factorial n upon z to the power n plus 1. Okay, so this would be nth derivative. Now if this is nth derivative, what is an? An is this, right? Nth derivative at z is equal to 2 upon factorial n, so that is going to be cancelled out, upon 2 to the power. So you have to find this at 2. So in place of z, there is going to be 2 to the power n plus 1. So this is your an. That is what you will need to expand this series. Okay, so we can write it 1 by z is equal to 1 by 2 minus 1 by 2 square z minus 2 plus 1 by 2 cube z minus 2 whole square. If I commit any mistake of plus minus, please forgive me and correct yourself. Minus 1 to the power n upon 2 to the power n plus 1 into z minus 2 to the power n plus dot dot. Okay. Now you have to find what? You have to find the radius of convergence, right? So in order to find radius of convergence, what you need, remember, try to recall that you need to find this limit n tending to infinite mod of an plus 1 by an. Do you know what is an here? An you have calculated. So you just put an plus 1 is minus 1 to the power n plus 1 upon 2 to the power n plus 2, right, into 2 to the power n plus 1 upon minus 1 to the power n. I hope this is clear. So once you will cancel it out, cancel these things, what you will be left with is, and there is mod, right? So do not forget to write mod, because there is going to be a minus sign, and that minus sign will come out as positive. So you will get value as 1 by 2. Now what would be radius? 1 by L star. This is 2. So radius of convergence is this. As well as you can do it in by a alternative method. So whenever you need to expand, your question or your function with the help of, you have to expand the analytic function, use binomial expansion, right, directly. So 1 by z, about which value you have to expand? 1 by z plus 2 minus 2, right? So you can write 1, take 2 common, right? What you will be left with? Take z minus 2 together, okay? 1 plus z minus 2 by 2, right, is equal to 1 by 2. 1 plus z minus 2 by 2 to the power minus 1. Binomial expansion is very easy. So one thing you should focus here, please remember this, that power of z is not negative. Here z minus 2 to the power is not going to be negative. So power of, in the expansion of the series, power of z will be negative when, in case of Laurent series, I will tell you how in my next video. Okay. So 1 by 2. This binomial expansion is easy. You can just 1 plus nx, then nn minus 1 by 2 factorial 2 into x square. So like that you can expand, right? Plus, so I'm going to remove this, because there would be 2, but 1 by 2 will be multiplied. That is why here it is 2 square. Z minus 2 whole square upon 2 cube minus dot dot dot. Okay. Now this series converges. To find the radius of convergence, what you will do? To converge this series, mod of z minus 2 by 2 should be less than 1, right? So mod of z minus 2 should be less than 2. So radius of convergence is r equal to 2, this value, right? Like we found domain of convergence as mod of z minus z naught less than r, so r will be 2 here. Okay. So thank you so much for watching the video. Do subscribe to the channel, and do subscribe to the channel, and stay tuned for my next video, where I will teach you Laurent series, which is very important, by the way, and bit different side, difficult. It may be difficult. So thank you.